So one of the things that we discovered in the last time was that when we're using the quadratic formula, this part under the square root told us something kind of interesting. When we got a negative number, when that b squared minus 4ac became a negative number, we got two imaginary answers. We also know from the previous one, when we got the square root of a positive number, we got 2 plus or minus, we got two real numbers as our answers. And an interesting thing is what happens if that part under the square root is 0? Well, the square root of 0 is 0, and so this whole square root part just disappears altogether. So plus or minus 0 actually gives us the same answer. So that's kind of interesting too. What we found here is this part under the radical is called the discriminant because it discriminates, and that's discrimination is not always a bad thing. In this particular case, the discriminant is telling us what kind of roots, what kind of solutions we're going to have. When it's negative, we get two imaginary answers. When it's positive, we get two real ones. And when it's 0, we get one real answer in there. So see if you can go ahead and answer this page, and then we'll take a look at the answers on the next slide. So again, if the b squared minus 4ac, this part under the radical is negative, we get imaginary or complex answers, they're sometimes called. How many of them? There's two of them, two imaginary roots. Two real roots we will get if it's positive. And if it's 0, again, this part just totally disappears. That means we're only going to get, this part is the only part left, minus b over 2a. The plus or minus the square root part disappears because this whole part's 0. And we're just going to get one answer, the minus b over 2a, and the one real double root. It's sometimes, because we talk about quadratics always having two solutions, we could say this one has one, but technically it's a double root. It's the same number twice that's in there. Okay, so here's the discriminant. Let's take a look at, this is a particular case when the discriminant, going back here. Going back here, we have where it's 0. When the discriminant comes out to be 0, we find that we have one particular root. In fact, if we look at this particular graph, we can see it comes down in its tangent right on the x-axis. In fact, the vertex is on the x-axis. The vertex and the x-intercepts actually ends up being the same thing. So this would be like the equation y equals x minus 3 times x minus 3, again, twice, so x minus 3 squared in there. It's the same one, it's the same solution twice. Okay, if the discriminant is positive, we are going to get two x-intercepts. It's going to cross twice when we do that. If the discriminant, the b squared minus 4ac, the part under the radical, is negative, then it never crosses the x-axis. If we look on that graph there, we can see that the parabola comes down but doesn't quite cross the x-axis there. That means we are going to get two imaginary roots, meaning that there are no x-intercepts in that parabola. Okay, so we're going to go ahead and do these one at a time here. But I do want to show you that these two questions on both sides, on the left and the right, are actually the same equations, just slightly different. But the x squared minus 4x plus 4 and the x squared minus 4x plus 4 are the same. Here we have it set equal to 0, and we're finding the roots or the solutions. And here we're setting it equal to y instead, and we're finding the x-intercepts. But the discriminant should help us be able to answer both of these questions, depending upon whether the discriminant ends up being positive, negative, or 0. That should be enough to tell us to be able to answer both of these questions. So go ahead and try to answer number 1 first on your own, and see what you get for the answers for those, and then we'll move on to the other ones. So looking at number 1 here, if we try to do the b squared minus 4ac here, we take negative 4, this is the b, we square it, we get negative 4 squared, minus 4 times a, which is 1 in this case, and c, which is 4, we get 16 minus 16. Hey, we got 0 for the discriminant. And of course, for this one, we're going to get the exact same thing. We get 0 for the discriminant. What is that 0 for the discriminant tells us? It means that we have one real double root, one real solution to this problem here. and it tells us on this one here that the graph is going to become tangent. We have one x-intercept, and it's exactly where the parabola is tangent to the x-axis. It just comes down and touches the x-axis and bounces off. That's what tangent means, where it comes and just bounces off it. Go ahead and try number 2 now. See if you can do that one on your own, and then we'll take a look at the answers. All right, so number 2 here, we got a b squared minus 4ac of 4. That means that there are 2 real roots, and for solving this equation, there's 2 solutions to this one, 2 real solutions. And this graph means it's going to cross the x-intercept twice in there. And sure enough, on the graph, it's crossing at 1 and 3. It crosses twice. And finally, question number 3. See if you can find, use the discriminant to find the answers to those 2. And we find here we got a negative value for the discriminant. That means it's going to be the square root of a negative number, meaning we have 2 imaginary roots, or you could say 2 complex roots, meaning that this graph never crosses the x-axis. There are no x-intercepts. All right. Cool thing about the quadratic formula, it gives you the 2 x-intercepts of the graph. Can it also give us the vertex? Let's see, that's interesting. Isn't the x-coordinate of the vertex always exactly halfway between the intercepts? And isn't halfway between the intercepts actually the average between the 2 intercepts? So if I found the average of these 2 numbers, I would actually find the x-coordinate of that vertex. So to find that, I would just add them up and divide them by 2 to find their average. So let's go ahead and try that. I'm actually going to use the quadratic formula here. I'm going to take the positive one. There's 2 roots, remember, in the quadratic formula. There's the positive one and there's the negative one. And I'm going to add the 2 of them together and then divide by 2. I'm going to find the average of them. So this is one root. This is the other root. We add the 2 of them together, find the average of them by adding them together and dividing them by 2. Well, the cool thing about adding a positive square root and a negative square root of the same thing is those 2 cancel out, and I'm going to get negative b plus negative b, which is negative 2b. They both have a common denominator, which is really nice, making it really easy to add them together, and that common denominator is 2a, so that stays 2a, and it's still divided by 2. I'm just going to reduce this, so there's different ways of doing this. I'm going to reduce this fraction here. Negative 2 over 2 is actually the same thing as negative 1 over 1, so we cross out those 2's and we get negative b over a, still divided by 2, but if we're going to take negative b over a and divide it by 2, we're actually dividing it by 2a's. All right, so we actually get negative b over 2a. So the average of these 2 roots, in other words, the x-coordinate of the vertex, is going to be negative b over 2a. So the x-coordinate of the vertex is found simply by using negative b over 2a. Once we know the x-coordinate, how do we find the y-coordinate? Well, we plug it back into the original equation. So let's find the vertex of this one. Go ahead and use negative b over 2a to find the x-coordinate of the vertex. And once you find that, plug it back into this equation for x to find the y-coordinate of that vertex. And sure enough, minus b over 2a is minus a minus 2, which is 2. Over 2 times a is 1. So that's 2 over 2, which gives us 1. So our x-coordinate of your vertex must be 1. Once we know the x-coordinate, we need to find the y-coordinate. We plug in the 1 back into the original equation, plug 1 in for x, plug 1 in for x, and we will get 1 squared minus 2 times 1 minus 15. And when we simplify this, we get the y-coordinate of the vertex to be negative 16, which tells us the vertex is at the coordinates 1, negative 16.